Hello everyone, dear students. In this exercise we're going to learn how to use LiDAR techniques. We also call terrestrial laser scanning to assess the deformation of this wall. Okay, this wall is experimentally constructed to assess the seismic stability of the wall, and we have some brick inside, and this is the columns, and these are the beams, and of course we have hydraulic system backside of this wall, and hydraulic system gives some shaking frequency like earthquake to this wall. Okay, and after the experiments, so we can assess how this wall is deformed. Okay, so that means we need two scans. First scan is before the experiment, and second scan is after the experiment. So in this way we can assess how this wall is deformed by giving the frequency. Okay. So now you see this wall is scanned before the experiment. This means there is no deformation yet. And in this picture, you can see it after the experiment. And we can see that easily the deformation here. We have deformation here. The loss of the volume and deformation is here also. Okay. And we want to know that how much after the experiment, how much this wall is deformed. We can use the laser scanning techniques. We have scanned the before scan and after the scan by comparing two point clouds, so we can assess easily level of deformations. Okay. So definitely I use the Cloudcompare software. I open the Cloudcompare software and I upload my data. This is my reference wall. Reference wall means the point cloud before the experiments. Okay, before the experiments. That means there is no deformation yet on the wall. It takes some time. I have here my wall. Okay, just give the shape. Just remember, my door is on the left side. This is the so definitely the first of all I have to give the RGB value. Okay, this is the original value, original color. This is the color, and the second I will upload my second file. It's a damaged wall. A damaged wall. It's the name is saying that this is the scanned after the experiments. Okay. It takes some time also. This is I've just uploaded my damaged wall. I select the damaged wall and give damaged wall to RGB file, RGB color. Sorry, RGB is I can turn off the reference wall. This is my damaged wall. Okay, you can see here some deformations. So the first thing I have to align both images together. First step. Okay, this is my reference wall and the damaged wall. So I select by control two point cloud, and I select this assign two clouds by picking at least 4 equivalent points. Okay, I will select this point, and this screen saying that select to be aligned entity. Aligned means damaged wall. Okay, line means a damaged wall. I select the damaged wall and OK. Now I can see these screenshots. I need 4 equivalent points for both image. The first of all, I turn off this align entities. Okay, so now I have only the reference point cloud, and I will select my first point. Okay, I will select the center of this target. It's just target. Just put first point here. R means reference. Okay. By clicking the right mouse button, you can change the position of the scan, and here is the second. I select the center. Okay, this is the reference one, and selected point coordinates you can see here. Okay, and this will be my R2, but totally is the 3 points here. Okay. Okay, this point, okay, this point, okay, this third point. Good. And now I have collected 3 points, 4 points actually, 4 points, R0, R1, R2, R3, okay? And the location of this point is here, okay? Because I have selected the center of target. So now the second step is I close the reference, I turn on the aligned entities. The same points I will select on damaged wall, okay? The same point. First, okay? The second, this A means align it, okay? Select this one. It's good, I'm finished. So now I have 4 points on the reference, okay, and the same points on aligned. And next I press the error. Error is I have to check the error. Error is good. I think you just bring it here. Error is, you see the error 0.007. This is perfect, and this is the 1 millimeter. This is the 2 millimeters, and this is 2 millimeters. Okay, and here is also the very small 1-2 millimeters. The maximum error must be 3 millimeters. Okay, if you have more than 3 millimeters, you have to put the points in one more time. Just press the align here, okay, the align and correct button, check. You see the final root mean square error alignment result is very good. It's only 1 millimeter errors. Okay, just save this screenshot for your report. Okay, now it's good. It's good. Just one. Okay, this is the perfectly aligned. Is good. Almost right there. If you want to be sure, just click the reference wall. Okay, reference wall, and select the cross-section tool. Okay, just bring half of this to be sure the alignment result, to see the alignment result. So now you see is almost perfectly aligned. This is another file. This is the left side is another file. It's very good. Okay, just close the door. So next step is we have to convert this point cloud to mesh format. And then what is the mesh? I already explained you in a lecture. Theoretical part, please select the reference wall, go to plugin, and select the Poisson Recon. This is the plugin. Select this. I think we need to increase it to 10. Okay, and check output density as a scalar field. Select advanced, but boundary we need the free. Okay, this free. Select free. And sample per node, I think it's better to 1, and this will be 0.25. Okay, and this point must be the very maximum. I think 12 is maximum, is good. Okay, in this case just select OK. Okay, it takes some time. So this is my mesh. Okay, I've created the mesh file. This is the mesh reference wall. Okay, I turn off my other two files. Now this is my mesh. Just you can close this console. We need the more spaces. Okay, this is my mesh file. But as you remember, I select the free. That means we have this also part. But I need to select only the wall part. So to do this, I have to select mesh first and go to faces. Go to faces here. Okay. I decrease this button. Okay. Is now 7.6 is I think is better. So, and I'll also bring this circle. Okay, that must be the same. Okay, and maybe it's better to write 7.6 here, and here is the 7.6. Okay, now I selected only the wall. Okay, so in this position I have to go to this point, filter point by scalar value. Okay, select this one, and it select me the mesh only from this and this range. Okay, export. So now perfect. So I will delete this draft mesh. So now I have this one. Okay, this is good, very good. And the next step is we need to calculate cloud to mesh distance. Okay, so now I have to turn off my file, and I select first the mesh, and damaged wall point clouds. Okay, I select the mesh as a reference. I go to select the compute cloud to mesh distance. Okay, so now you have to be careful that reference must be mesh reference and compare it must be damaged wall. Okay, so now I compute the cloud to mesh distance tool. It takes some time, please be patient. Okay, almost finish it. It's good. Now, yes, please press OK. Now OK. The first thing is we have to turn off the mesh. Okay, turn off the mesh and select the damage, because calculated cloud to mesh distance is located in damage wall point cloud. Okay, and now please pay attention, the color must be scalar field, and please go the active scalar field must be cloud to mesh. You just calculated this value. Okay, it's good. Now it's visible, select the visible. Good. Now if you see the range of the value, it starts from minus 0.09 to maximum is 0.061. That means the deformation is maximum 9%. Sorry, 9 centimeter, and the bulging part is 6 centimeters. Okay. Okay. For example, here you can see the dark blue. Dark blue means it's almost here. Okay, it's here. That means is approximately 8 centimeter is go the inside is deformed. Okay. For example, if I want to find only deformation is inside, I have just give here is 0.0 enter. Okay, and in this picture you can see the only I see the deformation is a minus. That means it's going inside. We lost some parts. Okay, is good. If you close and close again, zoom in and select these points, right? This point, and select this here. You see is here the minus 0.07, sorry, 8. That means the 8% is the going the inside. Okay, and save the save. And for example, what about here? We have some also the negative deformation. Just press here minus 0.01. It's a 1 centimeter is deformation. Okay, only 1 centimeter is deformation. It's a very good results. Okay, good. So I close it. Please screen this screenshot and save it the screenshot to your report. I select again the damaged wall. Okay, damaged wall. Now I select only the bulging positive deformation. So to do this I have to bring it circle back again, and here I have to write 0.00 enter. Now you can see here is only the positive the value is I have to select delete this one because it's creates some mess for understanding. Okay, and this is a damaged wall again. Because it's a zero bar, it's not very easy to see, but I increase the value here. For example, 1 millimeter is here is okay. So is I think is need to 3 millimeters. Is better to see the um, yes 3 millimeter. Yes. Okay, here is the bulging part. Okay, bulging part is going outside. So if I select the data, for example here, okay, here's 1 centimeter, 2 millimeter is going outside the deformation. Or here, you just want to select, press select this one, is only 6 millimeter is bulging. Okay, perfect. Okay, it's good. So when you finish with analysis, just close this one, and if you want to delete and delete, and select and delete. Okay, and select the damaged wall again, go to data and bring it to initial positions. Okay, so now I will show you how we can use X-ray functions. Just for example, select the cloud and turn off the damaged wall. Okay, just to understand it better, and select this convert a cloud to the distance function. Okay, and here you can see some the screenshot. This is the step means rasterization, but they're asking the size of the raster or pixel. Okay, so it's better to select 0.003. Okay, and active layer, just you can select RGB and the direction is X. Okay, because x-axis is perpendicular to the wall. Okay, and just upgrade. You can see the wall, just wall, and the next step is the hillshade. Okay, select the hillshade and generate. Okay, and here you can see initial wall texture. It's not deformed yet. Okay, um, deformed yet, but and we can do the same thing with deformed wall also. Okay, you can screen this screenshot, save it, and I close the window. Now I turn off the reference wall, turn on the damaged wall. Okay, damaged wall, and I select again this rasterization. The pixel size must be 0.003. Okay, cell height RGB, and direction is X. And upgrade. Okay, make bigger, and now hillshade, select again and generate hillshade. So now you see the X-ray of the wall after the experiment. You can see here is some loss of the volume, and here also, and here, and also this part. But the bulging part of the wall is, I can easily say this is the bulging part and this is the bulging part. Almost 1 centimeter is bulging. Okay, you can save it for the documentation, this screenshot, and add to your report. Close it. Okay, so after examining this X-ray damaged wall, we convinced that we have some loss of the volume on this brick. Okay, and if you want to identify how much volume in terms of centimeter cube or meter cube, you can use the Cloudcompare software to identify. So to do this, first of all, we need to cut only this part, okay? But now I select the damaged wall and give them the RGB true color here, okay? And select the damaged wall and select the cross section, okay? And limit only this part of the wall, okay, approximately, okay, this one, and here, okay. Zoom, right click, just to move the object, okay. This is this wall, this is my wall, sorry, not wall, it's brick, okay. This is the brick, this is the just brick, okay. It's here, this is just brick. And you see here we have some volume loss here, that's how much we will identify now. So when you finish the limiting of the brick, just export selection as a new entities, okay. Just press this one, perfect, just close. Now I turn off the main wall, and here you can see your selection wall, okay, damaged wall, this one. So I can change name, double click, okay, and maybe damaged wall, maybe damaged brick, okay, damaged brick is better, uh, enter, okay. So now the same thing I will do with reference wall, okay, the turn off and reference wall, go to reference wall, turn off the reference, turn on the reference wall, okay, and select the cross section, and you can keep the damaged brick, okay. So bring it, the limit, okay, is here, zoom in, okay, perfect. Let's bring it here, okay, good. Okay, perfect, almost finished, almost finished. Is the limit, okay, and new slice, okay. I turn off my main reference wall, okay, reference wall, I change the name also the brick, okay, just brick, reference wall, brick, enter, that's it. So I need these two file, reference wall brick and damaged brick, okay. So now I select both of them, damaged brick and reference brick, okay, and go to tools, volume, compute 2.5 D volume, okay. Now you can see this screen. So before means, look, please pay attention, before means source, you have to select the reference wall, it means the before, okay. And after is not reference but damaged one, okay, damaged one, and maybe leave empty, but we can interpolate, no problem, no problem. And step is the pixel size, 0.003 is better, okay. So now projection is of course by x. X is perpendicular to normal to the wall approximately. Okay. Now I press the update. I will enlarge update button. Here you can see my wall. Okay, my wall volume. Please check the results. Volume is minus 0.02. This is the meter square. Okay, if you convert this meter square to centimeter cube, it will be 2000 centimeter cube. Okay, this is the volume we lost here, most of them. Okay, the surface is the area of this surface is 0.187 the meter square. Okay, and if added volume is, we have no added volume here, but removed volume, we have a removed volume 0.02 meter square. Okay, so it will be 2000 centimeters square. Okay, perfect. If I can increase the number of precision, okay, 5, you can see this is the some changes, but this is the rounding. Rounding is working now. That's it. Okay, and we have main depth is 9 centimeter here. Okay, 9 centimeter. This the volume is approximately this much we lost. Okay, then when you finish, please take a screen of this image, screenshot for your report, and you can close it, window. That's it. So this was it today. If you have any question, just you can give me your questions. We finish today's exercise. So have a nice day. Thank you very much for your attention.